Hello and welcome to this channel, Intellimaths, where we'll be taking you through solving mathematics problem in the most simplest form. Today, we will be treating this topic, number bases. Though this topic might seem like the most simplest topic in mathematics, but trust me, there are many people out there that still find it difficult to solve problem under this topic. I can remember when I was in higher institution, there are still some of my colleagues that have issues solving problems under this topic, number basis. So in this video, we're going to take you through how to do conversion from one base to another. In this video, we're going to cover base 2 to 10. Of course, we have more than that. We have up to base 16, which is the hexadecimals. And looking at number bases, we have the most commonly used base is the base 2, which is the binary system, base 8, which is the octal system, and the base 10, which is the decimal system. Base 2 is binary, base 8 octal system, and base 10 is decimal. These are the most widely used bases, and we use base 10 on our day-to-day arithmetic activities. So let's get started. But before we continue, make sure you subscribe to this channel, Intellimaths, and follow our social media platforms, Facebook, Instagram. We are on Facebook, we are on Instagram, and TikTok at Intellimaths. Problems on number system. Like I told you, on this video, we're going to cover how to convert number from one base to another and how to perform basic arithmetic operation. That is the multiplication operation, addition operation, subtraction, and division across all number-based systems that we have. But before we continue, I would like to explain a concept to us. Our arithmetic digit ranges from 0 to 9. Now, in base 2 number system, we have only 0 and 1. This is base 2. In base 3, we have from 0 to 2. This is base 3. Base 4, we have all of this. Base 5, the highest number in base 5 is 4. The highest number in base 6, this is base 5. The highest number in base 6 is 5. As you can see, if you count, you have 1, 2, 3, 4, 5, 6. Base 7, the highest number is 6. Base 8, the highest number is 7. Base 9, the highest number is 8. This is base 9, and this is base 10. We have from 0 to 9. So, which means in each number system, the lowest number is 0. The counting starts from 0. And the highest number would be the last number in that base system. Like base 2, we have only 2 digits, which is 0 and 1. In base 3, we have 3 digits, which is 0, 1, and 2, and so on and so forth. Now, let's look at how to convert number from one base to another. I want you to pay close attention to this explanation because that is the foundation, that is the bedrock. What we are going to learn now is applicable to conversion in any base. Now, the first example we are going to solve now is we're going to convert a number in base 2 to base 10. convert 10101 base 2 to base 10. Now, to do this, to convert from base 2, I want you to take note of something. Conversion from base 2, from any base to base 10, you are going to use this method that I want to explain to you. And conversion from base 10 to any base, you are going to use the long division method, which I'm going to explain in this video as well. Now, let's look at this. We have 1,1,0,1,0,1 is a solution in base 2. Now, like I promised, I am going to teach you in the most simplest form to solve mathematics problem, from basic mathematics to advanced mathematics. Now, to solve this, to convert this to base 10, look at this. We have how many digits? 1, 2, 3, 4, 5, 6. These are 6 digits in this number. Now, let us assign power to each digit. So we start from the very last one. We start from 0, 1, 1, 2, 3, 4, 5. And what are we going to do in this regard? Then we pick each number. We pick each number starting from here. That is 1. We multiply the number by the base, the original base, which is 2, then raise to power of the power we assign to each number, each digit rather. That is 5. Then we add it. We move to the next number, which is 1, also multiply by 2 and raise to power of 4. Plus, the next number here is 0, multiply by 2 and raise to power of 3. Then plus, the next number is 1, multiply by 2 and raise to power of 2. Plus, followed by 0, multiply by 2 and raise to power of 1. Then plus 1 multiply by 2 and raise to power of 0. Now, let's do the mathematics here. The right one, 2 raised to power of 5. I always advise my students, don't train your brain with using calculators. So this is the way you can be a genius in mathematics, because solving this simple and basic mathematics with your head consistently will make your brain develop the mathematics ability. Now, let's solve it here. 2 raised to power of 5 will be 2. 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, that is 32. Which means 2 raised to power of 5 will give us what? Will give us 32. Then plus 1 times 2 raised to power of 4 will give us 16. Plus 0 times 2 raised to power of 3 will give us 8. Plus 1 times 2 raised to power of 2 will give us 4. Plus 0 times 2 raised to power of 1 will give us 2. Plus 1 times 2 raised to power of 0 will give us, and in the law of indices. So when we get to indices, I will explain better to you. Any number raised to power of 0 will give us what? Will give us 1. Now let's continue with the mathematics. 1 times 32 will give us 32. Plus 1 times 16 will give us 16. Plus 0 times 8. Any number multiplied by 0, or 0 multiplied by any number will give us 0. Plus 1 times 4 will give us 4. Plus 0 times 2. Don't forget, any number multiplied by 0 will give us 0. 1 times 1 will give us 1. So let's do the arithmetic, and whatever we get is our final answer in base 10. 32 plus 16, that will give us 48 plus 0 is still 48. 48 plus 4, that's 52. Plus 0 is still 52. Then plus 1 will give us 53. And that is in base 10. So we now we just converted 110,101 in base 2 to 53 in base 10. So that is how to convert any number base to base 10. Let's assume this is in base 3. We're going to follow this procedure to convert it to base 10. Let's assume it is base 8 here. We're going to follow this procedure to convert to base 10. Now, for clarity, I'm going to convert this 53 to base 10. 53 in base 10. I'm going to convert it back to base 2. And let's see if it's going to give us the same answer as we got here. Now, don't forget, when we converted this, our result was 53 in base 10. Don't mind, no matter. 53 in base 10. Now, we want to convert this 53 in 10 to base 2. Now, to do this, we're going to use the long division method, and our remainder will be the final result. Now, let's see, this is what I'm talking about. 53 divided by the base 2. Let's assume we want to convert from base 10 now to base 3. It will be divided by 3. Let's assume we want to convert to base 8. It will be divided by 8. Then we record our remainder in each division A. 53 divided by 2. That will give us what? That will give us 26. 26 times 2, that's 52. Then we have remainder of 1. 26 divided by 2 also will give us 13. Remainder of what? That's 0. 13 divided by 2 will give us what? Will give us 6. 6 times 2 is 12. Then we have remainder of 1. 6 divided by 2 will give us 3. Remainder of 0. 3 divided by 2 will give us 1. Then we have remainder of 1. 1 divided by 2 is impossible. That means we're going to write 0. Then we have remainder 1. If we now read, we read from bottom to top this way. It means our 53 in base 10 will be equals to 110,101 in base 2. As you can see, it is the same. We converted from base 2 to base 10 to give us this, and we converted this from base 10 to base 2 to give us this. Like I said earlier, this method is applicable to all bases. If you are converting from any base to base 10, you follow the method I used here. And when you are converting from base 2 to base, when you are converting from base 10 to any base, you follow this method. I repeat, when you are converting from any base, either base 2, base 3, base 4, base 5, and so on to base 10, you follow this method. And when you are converting from base 10 to any other bases, either base 2, you are converting from base 10 to 2, to 3, to 4, 5, and so on and so forth. You use this method. It is as simple as that. So we've treated 2 examples that way. Now let's go to example 3. Now we have we want to convert another number So that it won't look like we're doing magic from base 10 to base 10 to base 2. Don't forget, you use the long division method divided by 2 and you record the remainder. So 29 divided by 2 will give us, like I said, don't use your calculator, use your head. That will be 14 because 14 times 2 is 28. Then we have remainder 1. And 14 divided by 2 will give us 7, remainder 0. 7 divided by 2 will give us 3, remainder 1. 3 divided by 2 will give us 1, remainder 1. And 1 divided by 2, that is impossible. That means we have 0 and we have remainder of 1. When we read upward, we have 29 in base 10 equals to 11101 in base 2. That is as simple as that. Now, for clarity, I'm going to convert this number in base 2 back to base 10 and let's see how it goes. 11101 in base 2. Then that will be because don't forget, if we assign power from the back and starting from 0, we have 0, 1, 2, 3, 4. It's not compulsory that you do all this. So far you know what you're doing and you are sure of yourself, you don't put it. This is just meant for clarity and for basic understanding so that you know what has gone wrong here. Like what we did here, it won't be as if it's a magic or it's a rocket science. No, that's the essence of putting it. So far you know what you're doing, you may decide not to put the power. Now let's continue. This will be 1 multiplied by 2, which is the base. All right. Then raised to power 4. Then plus 1 times 2 raised to power 3 plus 1 times 2 raised to power of 2 plus 0 times 2 raised to power of 1. Then plus 1 times 2 raised to power of 0. That is 1 times 2 raised to power of 4 will give us, don't forget, don't use calculator, it's very simple, 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. And 8 times 2 will give us 16. Then plus 1 times 2 raised to power of 3, that is 8. Plus 1 times 2 raised to power of 2, that is 4. Plus 0 times 2 raised to power of 1, that is 2. Then plus 1 times 2 raised to power of 0. Any number raised to power of 0 is 1. So let's continue with the arithmetic. 1 times 16, that will give us 16. Plus 1 times 8, that will give us 8. Plus 1 times 4, that will give us 4. Plus 0 times 2, that will give us 0. Any number multiplied by 0 will give us 0. Then 1 times 1 will give us 1. Now let's do the arithmetic. 16 plus 8, that will give us 24. 24 plus 4, that will give us 28. And 28 plus 1 will give us 29 in base 10. You can see we converted 29 to base 2. We got this answer. And we now, for clarity, we decided to convert our result back to its original base, and we still get it right. So it is as simple as that. Now, let's move further now, and let's trace other bases other than base 2. Now, let's convert number from base 8 to base 10. Let's convert 1264 in base 8 to base 10. Like I said earlier, when you are converting from any base, all right, to base 10. You are going to follow this method that I explained to you, the multiplication and addition method. This is base 8. Like I told you, this is what we did there. We assign power to each digit. 1, raised to power 0, raised to power 1, 2, and 3. Then you pick each number one after the other, multiply it by the base, and raise the base to the power assigned to the number. It's as simple as that. Now, in this case, it will be 1 multiplied by, what is the base? 8. Then raised to the power of 3 plus 2 multiplied by the base 8 and raised to the power of 2. Then plus 6 multiplied by the base, which is 8, and raised to the power of 1. Then plus 4 multiplied by 8, which is the base, and raised to the power of 0. Now, this is it. 1 multiplied by, what is 8 raised to the power of 3? It's very simple. It's something you can do. That will be 8 times 8 times 8. 8 times 8 will give us 64. So 64, you can do it. It's very simple. 64 multiplied by 8. This will give you 32. You write 2, you keep 3. 8 times 6, that's 48. Plus 3, that's 51. That is 512. It means 8 raised to the power of 3 will give us 512 plus 2 times 8 raised to the power of 2 will give us 64 plus 6 times 8 raised to the power of 1 will give us 8 plus 4 times 8 raised to the power of 0 will give us 1. Okay, let's continue. 1 times 512 will give us 512 plus 2 times 64. You don't need to use calculator, just come to your playground. Let me put it that way. So 64 times, that is 4 times 2, that is 8. And this is 12. It gives you 128. So 2 times 64, that's 128 plus 6 times 8, that will give you 48. 4 times 1 will give you 4. Now let's do the arithmetic. 512 plus 128. Come to your playground again to do it. You don't need to use calculator. When you are doing things like this consistently, your brain will get used to it. And trust me, with time, you won't need to be doing all this before you say answers to basic mathematics operations like this. Now, 512 plus 128. 8 plus 2, that is 10. You write 0, you keep 1. This is 3 plus 1, that's 4. And this is 6. That's 640. So you add 48. Then you have 688. Then add 4. This is 12. You keep 1. This is 9. And this is 2. That is our final answer is 692. That is in base 10. So we just converted 1264 in base 8 to 692 in base 10. For clarity, let's convert this 692 in base 10 back to its original form in base 8. Our answer must be the same as this if everything goes on well, if we solve it correctly. So let's get it done now. Yes, like I said, for clarity, so that we'll be sure that we know what we're doing, let's convert 692 in base 10 back to its original form, which is base 8. And let's see. So 692 using the long division method divided by 8, which is the base we are converting to. And we're going to record the remainder here. Now, that 692 divided by 8, this is how to do it. The first two digits we have is 69. So 69 divided by 8 will give us 8. because 8 times 8 will give us 64. Now, subtract 64 from 69. Then we have what? We have 5 remaining. So that's not the end. Don't forget we still have 2 here. Put that 5 at the front of 2. Put that 5 at the front of 2. That will be 52. Then 52 divided by 8. That will give us 6. 6 times 8 will give us 48. And subtract 48 from 52. Then we have 4. So that means we have remainder 4. Alright? 86 divided by 8. We have 10. And remainder 6. Then 10 divided by 8. We have what? We have 10 divided by 8. We have 1. Remainder 2. And 1 divided by 8 is not possible. That is 0. Then we have remainder 1. So we read from bottom to top. Then 692 in base 10 will have equals to 1264 in base 8, which is the same as what we converted. We converted 1264 in base 8 to base 10, and we convert 692 in base 10 back to base 8. So that is that about that. Conversion you might want to do from any base to another base, we pass through this process. When you are converting from any base, either base 2, base 3, base 4, or base 5, like I said earlier, whenever you are converting from any base to base 10, you take this process. And when you are converting from base 10 to any other base, you follow this process. Now, let's solve an example whereby we won't be dealing with base 10 and we won't be dealing with base 2. I want to convert from 2 different bases that doesn't involve base 10 or base 2. Let's solve this example. We have to convert from base 3 to base 8. We have to convert 211 in base 3 to base 8. As for me, I always love to be descriptive in my solution so that anyone that wants to assess my work will find it very clear to assess. So the first thing I will do is, firstly, I'll let you know what I want to do. Convert 211 in base 3 to 10. That is how to approach this kind of question. When you have to convert from one base to another, which doesn't involve 10, you firstly convert the original number from the original base to base 10. And you now convert the base 10 equivalent of this number to the destination base, which is base 8. Now, let's see how it goes. Don't forget the procedure we do follow. That will be, you now pick this number one after the other. 2 multiplied by the base, which is 3, and raised to power. Don't forget, like I told you, it's not necessary that you put it as long as you know what you are doing. But for benefit of those that hasn't understand yet, we are to assign power to each of these numbers, starting from 0, 1, and 2. And this will now be raised to power of 2 plus 1 times the base, which is 3, raised to power of 1, then plus 1 times 3 raised to power of 0. Then is equals to, we have 2. 3 raised to power 2. That's 3 times 3, and that will give us 9. Plus 1 times 3 raised to power of 1, that is 3. And plus 1 times 3 raised to power of 0 will give us 1. We have 2 times 9, that is 18. Plus 1 times 3, that is 3. Plus 1 times 1, that is 1. So let's do the arithmetic. 18 plus 3, that is 21. Plus 1, and that is 22 in base 10. Now we just convert 211 in base 3 to base 10, which is 22. Now, moving forward, we have to convert this base 10 equivalent to base 8. So then convert 22 in base 10 to 8. All right. So don't forget the long division method that we do follow. You divide this number by the destination base, which is 8. Then you record your remainder here. 22 divided by 8, that is what? 2. 2 remainder what? Remainder 6, because 8 times 2, that is 16. 22 minus 16 will give you 6. And 2 divided by 8, that's impossible. It's 0, then remainder 2. So you read from bottom to the top. That means 22 in base 10 will be equals to 26 in base 8. 22 in base 10 will be equals to 26 in base 8, which implies that 211 in base 3 will be equals to 26 in base 8. It is as simple as ABC, even as simple as eating rice and beans. So, as you can see, any conversion operation you want to perform across all number-based systems will follow these two procedures. Either you are converting to base 10 and you are converting from base 10. You follow either of these two procedures to achieve your results. Now, we come to the end of the part 1 of the number-based system for today. The part 2 of this video will be talking about how to perform basic arithmetic operation across all number bases. That is multiplication, division, addition, and subtraction. But before we go, I would love to give us an exercise. Convert 1101 in base 2 to base 5. So I want to see how many of you will attempt this question and get the correct answer. So comment your answer. Put your answer in the comment below. And let's see who's going to get it right. And don't forget to subscribe to our channel and ring the notification bell so that you can receive updates about our next video as we continue to solve mathematics problem from the basic to the advanced mathematics. Don't forget to follow us on our social media platform. We are on Facebook, we are on Instagram, and we are on TikTok at Intellimaths Pro. So have a nice time. See you in the next. Hello, and welcome back to this channel, Intellimaths. In today's video, we'll be moving forward where we stop in number-based system. On the previous video, which is the part 1 of this video, we talk about conversions from one base to another. We solved different examples and to ensure that we understand the concepts better. In the previous video, do not forget, I gave us an exercise. The solution to the exercise given to us is on your screen. As you can see, it's being displayed. That is the solution and that is the answer. In case you attempt the question but you fail to get the answer, here is the solution for you on the screen. Now, let's move to today's topic. We will be dealing with arithmetic operations in number basis. We'll deal with the basic arithmetic operation in number basis. We are all conversant with base 10 and some of us got knowledge of base 2. But let's see how we perform arithmetic operation in number basis. In this video, we'll be dealing with additions and subtractions. In order to make it simple for us, like I promise to make mathematics solution looks and seems the most simple for us, I will start with the base that we are all conversant with, which is base 10. Then we'll move from base 10 to other bases. I want you to pay close attention to the techniques that we're going to approach to solve the solution. It is quite simple, but it is quite unfortunate that many of us, even graduates, they were just fortunate that the exams they've written doesn't touch some of these questions. And I'm telling you, many people find it difficult to solve arithmetic operations in number bases other than 10 and 2. Today, I'm going to demystify this for us. Let's get started. Like I said, we are going to start with the basis that we understand, which is base 10. Look at this question. Examples. Add 639 plus 683 in base 10. You have to add 639, 639 and 683 in base 10. This will be quite simple for us because we are conversant with addition in base 10. Look at it. 639, 683. 9 plus 3. That is what? That is 12. We understand, every one of us understand quite all right that we write 2 and we keep 1. What brings about this one? Many of us cannot explain. And that is the rudiment, that is the foundation of the problem we have in solving arithmetic operation in other bases. Stay tuned to this video as I'm going to explain and demystify the mystery behind this one that will keep to us. 3 plus 8, that is 11. We say plus this one will give us 12. Then we write 2. We still keep 1. 6 plus 6, that is 12. Plus 1 that we keep, that is 13. Then we now say our answer is 1322 in base 10. Now look at this. In base 10, don't forget we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, if we want to continue with the numbering system in base 10, we say we have 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. When we get to 20, we continue like that. Now, let's come back to the one we keep here. When you say 9 plus 3, that is 12, which exceed the threshold of digits that we could get in base 10. That means we have one set of 10 from that result. And what are we left with? We are left with 2. We write the remainder. And we have one set of 10. This one that we write means one set of 10. This this explanation, what I explained is very crucial for us to understand how to solve basic arithmetic operation in other bases. You will get it right when we get to solving arithmetic operation in other bases. Let's solve another example. This will not be in base 10, but it will be in base 2. Add 1011 plus 1011 in base 2. Look at this. Add 1011 plus 1011 in base 2. Let's get it done. 1011, then 1011 in base 2. Now, when we say 1 plus 1, that is 2. Don't forget, we are performing this operation in base 2. And 1 plus 1, which give us 2, has exceed the threshold of digits we could get in base 2, because base 2 digits are 0 and 1. Now, what do we say in this regard? We have one set of 2, because 1 plus 1 give us 2. That we have one set of 2. What are we left with? We are left with 0. Now, 1 plus 1 here give us 2, plus the one we've kept, one set of 2 that we kept outside. That is 3. 3s are also exceeded the threshold of the digit we could get in base 2. But from 3, we have one set of 2, then we have 1 as remainder. We are going to write that 1 that remains, because 1 is still within the threshold of digit we could get in binary. We write 1. All right, but we still have one set of 2 outside. 0 plus 0, that's 0. Plus 1 that we have, one set of 2 that we have outside, we write 1. And 1 plus 1 is what? That's 2. We cannot write it because it has exceeded the threshold of the digits we could get in binary. That is base 2. Then that means we have one set of 2 and our remainder is 0. Then we write 0. We write 0. Then we bring, since this is the last arithmetic operation in this context, we bring the one that we kept outside here. Then our answer is 10110 in base 2. If you see the same context of base 10, when you want to keep one outside, you turn that one is set of 10. But in base 2, it is set of 2, and so on and so forth. Let's solve another example on a number base that we are not conversant with. We are conversant with 10, and we are conversant to some extent with base 2 also. Let's solve another example on other base other than base 2 and base 10. Example 3. Let's add 153, 15. Let's add 153 plus 216 in base 7, 216 in base 7. 153 and 216. 3 plus 6, that is 9. That exceeds the number of the threshold of digits we could find in base 7. That means we have one set of 7. So when we deduct 7 from 9, what do we have left? 2. The remainder is what we're going to write here, which is 2. Now, 5 plus 1, 6, plus 1 that we have outside, that is 7. That is, we have one threshold of 7 again, remainder 0. We write 0. 1 plus 2, that's 3. Plus this one, that is 4. That means 153 plus 216 in base 7 will give us 402. So that is that about addition operation in number basis. So this approach is applicable to any addition operation you want to perform in any number base. Now let's move on to subtraction operation. Subtraction. Now we have this will be the fourth example now. Subtract. Let's firstly deal with the base 10 that we are conversant with. 223 minus 186 in base 10. We're going to subtract 223 minus 186. Let's get it done. That's 223 186. 3 minus 6 is going to give us a negative result, which we don't need, which is not needed here. Now, to get a positive answer, we look at the number, the next digit in the column, in the 10 column. So we borrow one from there. That one we turn to the base, which is 10. Then 10 added to 3 will give us 13. When we now deduct 6 from 13, then we get 7. Don't forget, we have 2 here, but we've borrowed 1 here, which we used here. So we are left with 1 here. 1 minus 8, it won't give us a positive answer also. So we move on to the next digit by the left. We borrowed another 1, turn it to 10, add it to the 1 we have left here. That is 11. 11 minus 8, that is what? That is 3. So we have 1 left here. 1 minus 1, that will give us 0. So that means 223 minus 186 in base 10 will give us 37 in base 10. So let's solve another example, another subtraction example, but this will be in base 2. Let's call this example 5 and subtract 110 1 minus 1 in base 2. 1101 1. Okay. Look at this. 1 minus 1. That will give us 0. 0 minus 1. The answer will not be positive. So we need to borrow 1 from the next digit by the left. So when we borrow 1 from here, we turn it to the base, which is 2, and we add it here. 2 plus 0, that is 2. 2 minus 1, that will give us 1. Don't forget we've used this 1. Then we are left with 0 here. 0 plus 0 minus 0 will give us 0. 1 minus 0, that's 1 in base 2. That means 1101 minus 11 in base 2 will give us 1010 in base 2. So next, let's solve subtraction operation in another base other than base 10 and base 2. Who's calling me? Let me silence this phone. So subtract 5117 minus 324 in base 8. 5117 minus 324 in base 8. Look at the bases. 7 minus 4 will give us 3. 1 minus 2, we have to borrow 1 from the next digit. Now, when we borrow 1 here, we turn it to 8, which is the base, and we add it here. That will now give us 9. 9 minus 2 will give us 7. We have 0 left here. We borrow 1 here, we turn it to 8. Add it to 0 that is left here, that is 8. 8 minus 3 will give us 5. And we are left with 4 here. That means 5117 minus 324 in base 8 will give us 4573 in base 8. It is as simple as this. Following this procedure, I will make this video to be as short as possible so that you won't get bored. And the next video will be dealing with multiplication and division in number basis. Multiplication and division operation in number basis. That will be part 3 of this video. And the previous video we deal about conversion. If you haven't watched that video, you can click on the link you are seeing above to watch the conversion, how to convert from one base to another. That's the part 1 of this video. And before we go, I don't just want you to take me for my word. Like, oh, I've shown you the procedure and that's it. In mathematics, you don't need to cram. Just understand the process and try to confirm if you are right. Then you are good to go. I want us to prove that our answer is correct. What are we going to do? Let's see if we convert this number in base 8 to 10 and we convert this number in base 8 to 10 also. We're now going to perform the subtraction operation in base 10. The answer we get, we're going to convert that answer back to base 8. If this procedure is correct, we must get this answer. But trust me, this explanation I want to give you now is just for us to be rest assured that our approach is correct. Nobody will want to use that. Imagine you are to solve a question which you have 30 seconds to spend. Going through that process will waste the whole of your time. But for the purpose of learning, I want us to prove that this short approach that we use is the most efficient and the most simple and the fastest means of solving arithmetic operation in number-based system. Now, let's firstly convert 5117 in base 8 to 10. It will be equal to 5 times 8 raised to power 3. Don't forget 0, 1, 2, 3. Then plus 1 times 8 raised to power 2 plus 1 times 8 raised to power 1, then plus 7 times 8 raised to power of 0. 5 times 8 raised to power of 3. That is 8 times 8 will give us 64. 64 times 8 will give us 512 plus 1 times 8 raised to power 2 will give us 64. Then plus 1 times 8 raised to power 1 will give us 8 plus 7 times 8 raised to power of 0 will give us 1. Now, 5 times 512. Let's do it here. 512 times 5. This is 10. That's 0, 1. 5, 6. 5 times 5, 25. We have 2560 plus 1 times 64, 64. Plus 1 times 8, 8. Plus 7 times 1, that is 7. Okay? Two 560 plus 64. We have 4, 12. We have 26, 24 plus, okay, that's 26, 24 plus 8. We have 2, with 3, 6. Then 26, 32 plus 7. We have 9, 3, 6, 2. Okay, we have 2, 6, 3, 9. This is in base 10. So the next thing now, we're going to convert this 3 to 4. Also, we're going to convert it to base 10. 3 to 4 in base 8. Let's convert it to base 10. We have 3 times 8 raised to power of 2 plus 2 times 8 raised to power of 1, then plus 4 times 8 raised to power of 0. This is 3 times 64 plus 2 times 8 plus 4 times 1. 64 times 3 is going to give us 192. Then plus 2 times 8 will give us 16. Then plus 4 times 1 will give us 4. Let's say 192. This plus this will give us 16 plus 4 will give us 20. 192 plus 20. This is 212 in base 10. Now, let's now perform the subtraction operation between these two base 10 equivalents. This will now be 2639, then minus 212. Both are in base 10. 9 minus 2, that is 7. 3 minus 1, that is 2. 6 minus 2, that is 4. Then 2. 2 minus 0, of course, is 2. Then we have 2427 in base 10. All right. Now, in order to now get our final answer, you can see that we've performed the subtraction operation in the base 10 equivalent, and we get this. We will now convert this back to base 8. Let's see what we're going to get. Now, don't forget, okay, let's do it here so that we'll be able to compare our answer easily. Let's do it here. So, 2427 in base 10. We want to convert it to base 8. Then we divide by 8. Then we record the remainder here. Now, 2427 divided by 8. Let's check it out. So let's firstly pick 24. Right? So 24 divided by 8, that's 3. So 24, 2 divided by 8, that's 0. We merge it with 7. 27 divided by 8, that's 3. Now 303 times 8, this is 24 equal to 8 plus 2. 8 times 0, 0 plus 2, this is 2. This 8 times 3 is 24. That's 24, 24. So 24, 27 minus 24, 24, which it means we have remainder 3. Now, 303 divided by 8. Okay, yeah, 8 in 30. We have 3 also. That's 24. 30 minus 24, that's 6. We put the 6 here. So 63 now divided by 8. 63 divided by 8, that is 7. So remainder 7. So because let's do the let's clarify it. If you say 37 times 8, 7 times 8 will give us 56. 8 times 3 24. 24 plus 5, that's 29. So if we deduct 29, if we deduct 296 from 303, we borrow 1, we put it. We have 0 here. We cannot borrow anything. We come here, we borrow 1, turn to 10, put it here. We now borrow 1 from here, turn to 10. This will be 13 plus 6. We have 7. We have 9 left here. 9 minus 9, 0. We have 2 left here. 2 minus 2, 0. So that is the remainder of 7. 37 divided by 8. That is 4. Because 8 times 4 will give us 32. And we have 5 as the remainder, because 37 minus 32 will give us 5. 4 divided by 8, impossible. We have 0 and remainder 4. We read from bottom to up. That shows 24, 27 in base 10 is equals to 4, 5, 7, 3 in base 8. As you can see, it's the same thing as the answer we get when we perform the subtraction operation directly in the base. We just use this to prove our answer that our approach here is very correct, 100%. So that is that about that. To learn more about conversion from one base to another, like I said earlier, go to the part 1 of this video. Then you learn much more about how to perform conversion from one base to another. So we get to the end of this video for today. Don't forget to subscribe to our channel and click the notification bell so as to receive updates whenever we release new video about mathematics. Our aim is to make sure you do develop intelligence in mathematics. Don't forget to follow us on our social media platform. We are on Facebook, We are on Instagram, and we are on TikTok at Intellimaths Pro. See you in the next video. Thank you. Hello, and welcome to this channel, Intellimaths. Today, we will move further in treating number-based system. Today, we'll be dealing with multiplication and division in number basis. So on each section, we're going to treat 3 examples each, which in total will be 6 examples. In multiplication, we have the first example here to be 402 multiplied by 13 in base 10. Four zero two times 13 in base 10. So this is very simple for us because we are used to number in base 10. We arrange it this way. So 3 multiplied by 2, that is 6. 3 multiplied by 0, 0. 3 multiplied by 4, that is 12. 1 multiplied by 2, that is 2. 1 multiplied by 0, 0. 1 multiplied by 4, that is 4. In total, we perform addition operation here. Then we have 6, 2, 2, then 5. This is our answer. So 402 in base 10 times 13 in base 10 will be equals to 5226 in base 10. It is very simple. So the next example here, let us go to base 2 example. We have 111 multiplied by 110 in base 2. We have let's arrange it 111, 110, both in base 2. So 1 times 0, 0 times 1, that's 0, is 0 and 0. 1 times 1, that is 1. 1 times 1, that is 1. And 1 times 1 again is 1. This again, 1 times 1, 1, 1 and 1. Then we perform addition operation. 0, 0 plus 1, that's 1. 0 plus 1, that's 1. 1 plus 1, that is 2. Don't forget, 2 is above the number we can have in base 2. So that means we have one set of 2. Then remainder 0. Then we write 0. That means we kept 1. 1 plus 1, that is 2. 2 plus the 1 that we kept, that is 3. So that means we have one set of 2, then remainder 1. Then we write 1. We are still keeping 1. 1, this is 1. We are left with 1. So plus the 1 that we kept, that is 2. That is one set of 2, remainder 0. Then we add 0, then 1. That means 111 in base 2 multiplied by 110 in base 2 will be equals to 101010 in base 2. It is as simple as that. Now we move on to the third example, which is multiplication operation in base 5. So if you want to learn about addition and subtraction in number basis, check part 2 of this video. As you can see at the top, check part 2 of this video. That's where we talk about addition and subtraction in number basis. So the addition operation that we perform here, you will understand it better. That is if you haven't watched the addition subtraction video earlier. So you can check it out on this channel. So let's go to the third example, which is in base 5. 242 in base 5 times 14 in base 5. We have 242, we have 14, all in base 5. Now pay attention to this. 4 times 2, that is 8. It is more than the digit we can find in base 5. So that means we have one set of 5. The one that we have, if we deduct 5 from 8, we have 3 left. So remainder 3. So we're going to write the 3, and with this, we keep one set of 5 outside. Now, 4 times 4, that is 16. All right? Plus 1 that we kept outside, that is 17. So that shows we have 17. We're going to see 3 set of 5. That will give us 15. Then remainder 2. Then we write the 2 here. That means we are having 3 set of 5 outside. Now, 4 times 2, that is 8. We have 3 outside. 8 plus 3, that is 11. In that case, that means we have 2 set of 5 in there. Remainder 1. So we write the 1. Since that's the last operation in this row, then we bring these 2 here. Now, we just finished the first digit, which is 4. So let's perform multiplication with 1 too. 1 times 2, we have 2. 1 times 4, we have 4. 1 times 2 again, we have 2. Then addition operation here, we have 3, 4. 1 plus 4, that is 5. That is, we have one set of 5, but remainder 0. Then we write 0, we keep one set of 5 outside. 2 plus 2, that is 4. Plus this one, that is 5. That shows we have one set of 5 again, then remainder 0. Then we write the 0 here. Since this is the last operation, the one that we kept outside, we bring it here. And that is it. So that means 2, 4, 2 in base 5 times 1, 4 in base 5 will be equals to 1, 0, 0, 4, 3 in base 5. So it is as simple as that. You can see that we follow the same approach, the same procedure in solving it. What is required is your attention to details so that you not make any mistakes. Let's go on to division. As we did in multiplication, we have 3 examples under division too. The first one is in base 10, the second one in base 2, and the third one in base 5. Now, 225 in base 10 divided by 15 in base 10. We use the non-division method because that is the simple and fast method to perform division operation. 2 divided by 15 is not possible. Then we combine the second digit. So 22 divided by 15, that is 1. 15 times 1 will give us 15. We want to determine the remainder here. 22 minus 15, that is 7. We bring down, since 15 cannot go in 7, we bring down the 5, the remaining 5. 15 in 75, that is 5. 15 times 5, that will give us 75. When we deduct 75 from 75, we have 0. Now, this means 225 in base 10 divided by 15 in base 10 will be equals to 15 in base 10. It is as simple as that. So let's go to the second example, which is in base 2. 100 divided by 11 base 2. We use the same method, 100 divided by 11. We record our answer at the top here. But one thing I want us to take note is this. It is the same approach. We found base 10 easy because we are used to base 10. It has become part of us. As we have multiplication table in base 10, so also we have multiplication table in other bases too. We have multiplication tables in base 2, base 3, base 4, base 5, and so on. So subconsciously, we are making use of that multiplication table in our division in base 10. But since we are used to it, it seems not to notice. But I'm going to expose it and explain how it is applicable in division to us. So let's pay attention and concentrate. Now, let us go to the multiplication table for the divisor here, which is 1, 1. Now, in order not to waste much of our time, we can complete the multiplication table for ourselves. But what we are aiming is the first number that we want to perform operation on. You can see 1, 1 is greater than 1, 0. That means we have to attach the next digit. So 1, 0, 0 now is greater than 1, 1. So we now go to the multiplication table and stop at any value that is closer to this value. Yeah. So let's check it out. We have 1, 1 times 1, 1, 1 times 2. So in base 10, 1, 1 times 1 will give us 1. Will give us 1, 1. But in base 2, it is also 1, 1. In base 10, 1, 1 we call it, in base 10 we call it 11 times 2 will give us 22. But in base 2, it will not be 22. Let's check it out. 1, 1 times 2. So this is 2 times 1. That is 2. We cannot write it because it's more than the number of digits you can have in base 2. Then that means we have one set of 2, then remainder 0. Then we write 0. That means we have one set of 2 kept outside. 2 times 1, that is 2. Plus the one we have outside, that's 3. That shows we have one set of 2, then remainder 1. Then we write this. We have 1, 1, 1, 0. So look at this. We have, what is the digit that is closer to 100? This is closer, but it's above, so we cannot use that. The one that is below that is closer is this. That means we can have in base 2, 1, 1 can go in 100 one time. Then when we multiply it, we have 1, 1. Let's deduct 1, 1 from 100. 0 minus 1 is impossible. We borrow 1. We have 0 here. We cannot borrow any 1. So we come to the very first digit. Borrow that 1. Turn it to the base, which is 2. Add it here. This 0 turns to 2. Now borrow another 1 from here. Turn it to the base, which is 2. Add it to this 0. That is 2. 2 minus 1 will give us 1. Don't forget, we are left with 1 here. 1 minus 1 will give us 0, and we are left with 0 here. Now, 11 in 1 is not possible. Then we bring down the next digit, which is 1. Excuse me, it is not 11 because we are operating in base 2. It is 1, 1. So 1, 1 divided by 1, 1, that is 1. That is 1, 1 times 1, 1 will give us 1, 1. This is now 0, 0. So we bring down the next digit, which is 0. 1, 1 in this, it is 0. We bring down the next digit. 1, 1 in this, it is still 0. So our answer now will now be 1, 0, 0, 1, 0, 0 in base 2 divided by 1, 1 in base 2 will be equals to 1, 1, 0, 0 in base 2. Now, if you want to confirm, if you have the time, maybe you are being skeptical about your answer, that how are we sure we are even correct? I've explained this in the previous video. You can just convert each of these numbers to base 10 first. Perform the division operation in the base 10 equivalent, and now convert your answer back to base 2. Now, if you want to learn how to do the conversion, go and watch the part 1 of this video, where we talk about conversion in number base, how to convert number from one base to another. There you will understand how to do the conversion, and so you can confirm your answer if you are right or wrong. So let's go to the third example. Example 3. 1, 4, 2, 3 divided by 24. That's in base 5. We're going to use the same approach. 1, 4, 2, 3, then 2, 4. Now, in order to guide us so that we will not do mistake, let's follow the same approach. Let's write out a multiplication table of 24, but in base 5. And we're going to stop at any number that we see is closer to the first digit that where we want to perform our operation. Now, let's check it out. 24 times 1 in base 5, don't forget, that's 24. Now, 24 times 2 in base 5. Don't forget, in base 10, 24 times 2 will be 28. No, sorry, in base 10, 24 times 2 will be 48. But no, we are not dealing with base 10 right now. We are dealing with base 5. So the multiplication operation will be in base 5, because we want to extract the base 5 multiplication table of 24. Now let's check it out. 24 times 2. Now 4 times 2, that is 8. All right, in base 10, that's 8. But 8 is higher than digits we can find in base 5. So that means we have one set of 5 already. Remainder what? 3. Then we write the remainder. 2 times 2, 4. Plus 1 that we have outside, 5. That means we have one set of 5, remainder 0. And that is 103. 103. Now 24 times 2 in base 5 is 103. Now let's check the second. 24 times 3. So 4 times 3, that's 12. 12 is higher than the digit you can find in base 5. So how many 5 are we going to see in 12? That's 2. That means we have 2 sets of 5. Then with remainder 2, we write the 2. We have 2 outside. 3 times 2, that's 6. Plus this 2, 8. That shows we have one set of 5, remainder 3. Then we write 3. Since that's the last operation, we bring all the. Well, that means 24 times 3 in base 5 will be 132. So Let's see 24 times 4. 24 times 4. 4 times 4, 16. How many 5 are we going to see in 16? That's 3. That shows we have 3 set of 5, remainder 1. We write the 1, we have 3 outside. 4 times 2, that is 8. Plus 3 that we have outside, that is 11. How many 5 are we going to see in 11? That is 2. We have 2 sets of 5, remainder 1. We write the 1. Since that's the last operation, we bring forward the 2. It means 24 times 4 in this 5 will give us 211. Now let's go back to our division. Now 142 divided by 24. We look at the number that is closer to 142 and lesser. That is 132. So 132, 24 times 3 gives us 132. That means 24 in 142 will be 3. So 24 times 3 now give us 132. We want to determine the remainder. Now let's deduct 132 from 142. 2 minus 2, that is 0. 4 minus 3, that is 1. 1 minus 1, that is 0. So 24 cannot go in 10. We bring down the remaining digit, which is 3. Now, 103 divided by 24, don't forget we have it here, and that is 2. So 24 times 2, 103. We have 0, 0, 0. That means 1423 in base 5 divided by 24 in base 5 will be equals to 32 in base 5. It is as simple as this. So you can pay attention to it, solve many examples on your own, and if you have any question, you can post it in the comment section. Then we will attend to it, or you can message us on our social media platform, on Facebook, on Instagram, and on TikTok at Intellimaths Pro. Make sure you follow us on our social media and subscribe to this channel. Turn on the notification so that you receive real-time notification about our updates. So we come to the end of the number-based system. Trust me, everything we discuss in the 3 parts of this video, part 1, part 2, and this part, which is part 3, if you pay attention to it, you will find all operation in number base as simple as anything. We're going to help you in combining all the 3 videos into one, in case you want to have it in one video. Stay tuned and watch out. Thank you and have a nice day. Subscribe to our channel and ring the notification bell to get our updates in real time. Intellimaths will help you develop intelligence for mathematics.